Welcome to the May 2025 Edexcel GCSE Paper 1. This is the non-calculator paper walkthrough. Okay, find highest common factor of the two numbers. So first thing I'm going to do is split up 54 into a product of its prime factors. It's 2 times 3 cubed. And I'm going to do the same with 120. Split those up into each of their prime factors. And we have a 3, a 2, a 2, a 2, and a 5. So 120 is 2 cubed times 3 times 5. And there's a number of ways of doing this. You can just look and see what they have in common. You can draw Venn diagrams if you like. Either way, there's a 2 and a 3 in common, so the highest common factor is 6. Question 2, discrete random variable. Well, we know the probabilities of a discrete random variable will sum to 1. There are twice as many blue counters to green counters, so we're going to call the probability of taking a blue counter 2x and green x. 0.3 plus 1 is 0.4, so add together the 2x and the x to that and we'll get 1. Subtract 0.4 from both sides, collect the x's together, divide by 3, x is equal to 0.2, 2 lots of x, which is the blue probability, is therefore 0.4. We know there are 45 counters in the bag. So to work out the total number of counters, we'd need to divide 45 by 0.3. I've times the top and bottom by 10 and carried out the division. So there's 150 counters in the bag altogether. Okay, when x is when x is negative 2, y is negative 2. When x is 0, y is 4. When x is 1, y is negative 2. And when x is 2, y is 2. Then have a go at plotting those points. So negative 3, 2, negative 2, negative 2, negative 1, negative 4, 0, negative 4, 1, negative 2, and 2, 2. And here's my best effort. I'm sure yours will be better than mine. And there we go, a nice parabola shape. Minimum point is going to be halfway between 0 and minus 1. You can see it on the graph. So x will be negative 0.5. And when you plug that in, you get negative 4.25 out. You can do the calculation if you want to, but negative 0.5 and negative 4.25 are the coordinates of the turning point, the minimum point in this case. Question number 4, this is about the chocolates in the box. So a seventh of them are dark, so a seventh of 280 divided 280 by 7 is 40, so 40 dark chocolates. Take those away from the 280 means we're now dealing with 240 that are either milk chocolates or white chocolates. And so we split 240 in the ratio of 1 to 3, add your 1 and 3 together to make 4. 240 divided by 4 is 60, so 1 part is worth 60. 3 parts are therefore the number of white ones, so 60 times 3 tells us is 180 white. So we've got 180 to 40 as the ratio of the number of white chocolates to the number of dark chocolates. 180 to 40, I've simplified that to 18 to 4, halved it again, 4.5 to 1, so n must be 4.5. Now, milk chocolates are not part of that calculation, so if you take 10 milk chocolates out of the box and eat them, then the ratio of the white chocolates to dark chocolates is not going to change. There's still the same number of white chocolates and dark chocolates in the box. So that ratio, eating those 10 is not going to change our value of n in A. Question number 5. I take the numbers in standard form. I'm just going to turn them into ordinary numbers, add them and turn them back into standard form. You can, if you want to be clever, leave the numbers in standard form and rewrite 9.8 times 10 cubed is 98 times 10 squared and then add them. Or you can write 5.7 times 10 squared is 0.57 times 10 cubed and then add them. Anyway, if you do it correctly, you'll get 1.037 times 10 to the 4. That's the only correct answer. Question number 6. We've got an equilateral triangle and a square, so we know the angles inside those are going to be 60 and 90. Summing 60 and 90 gives us 150, and so the interior angle of this polygon is 150. I've used the equation for generating the interior angle of a regular polygon, so 180 lots of n minus 2 all over n, that must be equal to the 150 we've calculated. Multiply both sides by n and expand it out. Bring the 360 onto the right, 150n onto the left, and divide by 30, so n is 12. If you calculated the exterior angle as being 30 and divided 360 by 30 to get 12, that's absolutely fine. Question 7a, we can just cancel a 2 minus m. So one of the 2 minus m's at the top and the 2 minus m at the bottom of the fraction will go, and we're just left with 3 times 2 minus m. Expand that out to get 6 minus 3m. For the inequality, add 8 to both sides, subtract x from both sides, times both sides by 2, divide both sides by 3, and you can see we can solve the inequality. I've turned it around, you don't need to do that, but x is greater than or equal to 10. For the sandwich inequality, subtracting 4 from every part and then halving every part, we get 2.5 is less than y is less than 4. Question number 8. To prove that a pair of triangles are similar, we have to prove that they have the same angles inside them. So the first step to doing that is that angle EAD and CAB is going to be the same angle, because it is literally the same angle. ADE and ABC are going to be the same because they are corresponding angles. That's because ED and CB are parallel lines. And then lastly, well, if 2 out of the 3 angles in 2 triangles are the same, the third one is automatically going to be the same. They're also corresponding here. AED and ACB, they're both right angles in this case, and those are corresponding angles, or they're just the third angle in a triangle, the 2 triangles that already have the same 2 other angles. The point being is that all 3 angles are the same in both triangles, and therefore we can reach the conclusion that the 2 triangles are similar, and that's what the question wanted us to prove. Okay, for part B, because they're similar, we can you sort of pair up the lengths. So AE and then AC, which is 18, and then 20 and 30. The ratio of those are going to be the same. Timesing both sides by 18, we can get AE to be 2/3 of 18, which would be 12. And then to find CE, we can subtract 12 from 18 to get 6. There are other ways of doing that one. Question 9, a few ways of doing this one. If you've got tracing paper, you can kind of draw the shape on the tracing paper and put your pencil in at various different points to test it and find the point, the centre of rotation by doing it that way. You can just look at it and work it out. Compare the points of the coordinates 2, 1 and -2, 3, and you see at -1, 0, the sort of the iron bars that would connect them are the same and identical as it's being rotated. Anyway, we need to see the words rotation, we need 90 degrees anti-clockwise, and we need the centre -1, 0 for the marks there. For enlargement, the centre of enlargement is -1, -3. So I'm actually going to plot that point. This is one way of doing it. There are other ways of doing it. I'm drawing the 3 lines that connect up the vertices of the triangle to the centre of enlargement. And then I'm drawing a little x halfway along, and then joining up those x's. I chose halfway because it's scale factor of a half. Join those up and we get our new triangle. Okay, consecutive square numbers. Well, if my first, square even numbers, my first even number is 2n, the next one's going to be 2n plus 2, so if I square both of those and subtract, it will find the difference between the two consecutive square even numbers. All that remains is for us to do a little bit of algebra, expand it out, collect the like terms, factorise out of 4, and we can quite clearly see that the difference between those two is going to be a multiple of 4, which is what the question wanted. Question number 11. So we've got two sets of proportionality going on. The first one is an inverse proportion, so it tells us that t is inversely proportional to w. We're going to turn that into an equation, t equals k over w, where k is a constant of proportionality. We know that t is 20 when w is 6. Substitute those in, multiply both sides by 6, and for this particular case, k is going to be equal to 120. And so our equation connecting t and w is t equals 120 over w. Now, the question wants us to deal with t being 48, so I'm going to substitute that in now. We could do this later, but I've done it first. So I've multiplied by w, divided by 48, and simplified down, and we get w being 2.5. Now we also know that w is proportional to the cube root of d, so I've written that w is proportional to the cube root of d, helpfully turning that into an equation, w equals k times the cube root of d, and I'm going to substitute w for 1 and d for 8. Those are the values it gives me in the question. Cube root of 8 is 2, divide by sides by 2, we know that k is a half, so our equation that connects w and d is w equals a half times the cube root of d. We worked out that w is 2.5, so I'm going to substitute 2.5 for w and solve the equation. Divide both sides by a half, we'll get 5 equals the cube root of d. Cube both sides, d is going to be 5 cubed, which is 125. Question number 12, so gradient at the point when t equals 3. I draw a tangent at that point where t equals 3, and I've just picked 2 points that are far enough apart to be able to calculate the gradient. So I've done one where x is 4, and then another one where x is 1. The y-coordinates at those 2 points are 52 and 22, so it would be 52 minus 22 over 4 minus 1. That's the difference in y divided by the difference in x. In this case, 30 over 3, which comes out as 10. So the gradient of this line is 10. Anything between 8.5 and 11.5 for a gradient is acceptable here. And that is, of course, measuring acceleration, or if you prefer, change in velocity. Okay, for B, it asks us to split it up into 3 strips. So I'm going to draw one strip going up at 2. I've already drawn a line at 4, so I'm just going to extend that from where it meets the curve. And we've got the area underneath the curve is what we're trying to calculate. So starting with assuming it's a triangle, and then we've got 2 trapeziums. So the first triangle at half times 2 times 30. The trapezium between 2 and 4 will be a half times 30 plus 50 times 2, and then the final trapezium between 4 and 6 will be a half times 50 plus 60 times 2. And those numbers are actually deliberately quite nice, and we can add them together to get 220 meters as our best guess. Question 13, so I'm going to work out each one of these recurring decimals as fractions. So for the x one, x is 0.2 recurring, multiply both sides by 10, 10x is 2.2 recurring. The difference between 10x and x is 9x, the difference between 2.2 recurring and 0.2 recurring is 2, so x is 2 ninths. For the y, I'm going to multiply both sides by 10 to bring the recurring decimal part up to the decimal point. We then have 2 recurring decimals, so I'm going to multiply both sides by 100, giving us 1000 y equals 681.81 recurring. and then I'm going to work out the difference between those two. So 1000y take away y is 990y, and 681.81 recurring take away 6.81 recurring. The recurring bits cancel, leaving us with 675. Divide both sides by 990, we get y is 675 over 990, and I simplify that down. Divide by 5, and then divide again, and it simplifies to 15 over 22. The question wants us to sort of work out x times y, so we now have those written as fractions, so 2/9 times by 15 over 22. I'm going to cancel first, so 15 over 9 cancels to 5 over 3, and 2 over 22 cancels to 1 over 11. 1 times 5 is 5, 3 times 11 is 33. This fraction is 5 over 33. Question 14, it's a probability question. Those are the digits from 1 to 9. There are 4 even numbers and 5 odd numbers. You don't have to do a probability tree, but if you like a probability tree, here's my sort of mediocre effort at doing one. We've got branches for an even and odd choice, and then follow-on branches for even and odd choices. Okay, so working out the probability that the sum of the two balls will be an even number. Well, there are two ways of that happening. You can pick two even numbers and add them and you'll get an even, or you can pick two odd numbers and add them and you will be getting an even. So the probability of picking two even numbers is 4/9 times by 3/8. The probability of picking two odd numbers is 5/9 times 4/8, so the product of those two fractions and add them is 32 over 72. For the product being even, well, that could be an even and an even and odd, or an odd and an even. However, to make my life slightly easier, I've just gone, well, it's basically anything that's not an odd and an odd. So if I find the probability of it being an odd and subtract that from 1, just fewer calculations to do, you'll get the same answer even if you did the other 3 and added them together. In this case, it comes out as 52 over 72. Now, because 52 over 72 is bigger than 32 over 72, the chances of the product being even is larger, and therefore I'm afraid, Lee, you were wrong in your statement there, and it is in fact the other way round. It's more likely that the product will be even than the sum. Okay, for the histograms, we're looking at the 20 to 40, so I'm going to put a couple of extra lines in at 20 to 40. I'm working out the area of each of these rectangles. With a histogram, it's the area that represents the frequency, so the first one's 3 times 10 is 30, and then we've got 5 times 10 is 50, and so on. Those represent all of the total frequencies. Now, between 20 and 40, we've got a 50 and an 80. And so it's going to be 50 plus 80 out of the sum of all of the rest. 30 plus 50 plus 50 plus 80 plus 40 plus 150. So that is 130 out of the sum of all of them. There are 400. You can leave it as 130 over 400. I simplified it to 13/40ths. But either would be absolutely fine here. Question 16, rationalising the denominator. I'm going to take 35 over root 7 and multiply it by root 7 over root 7. The numerator will therefore be 35 root 7. Root 7 times root 7 is 7. And the 35 over 7 simplifies to 5. So the whole thing simplifies to 5 root 7 for A. For B, I've done a little simplification just to make the numbers nicer, because this is a non-calculator paper. Root 7 is the same as root 9 times root 3, or if you prefer 3 root 3. So my fraction's now 3 root 3 minus 1. all over 2 minus root 3. I'm going to multiply by its conjugate pair. That is multiply by 2 plus root 3 over 2 plus root 3. Essentially, I've taken the denominator and changed the sign. Now that fraction is equivalent to 1, so I'm not changing the value of the calculation here. This is why it is a simplification. We're not changing what we're playing with, we're just changing the way it looks. Multiplying the numerators together, it's a double bracket expansion. I've just ploughed straight in. Multiplying the denominators together, it's a difference of 2 squares. We end up with 4 minus 3. It simplifies to 7 plus 5 root 3 once you collect all the bits together. So A is 7 and B is 5. Question 17. To make this read slightly easier, I've split up the two sections. So the first one I'm going to do is 3 lots of g of h of x. So I'm going to embed h of x inside g of x. H of x is 2x squared minus 1, so I'm going to plug that and replace the x in g of x with it. So we get 3 lots of, and then the compound function 1 minus 3 lots of 2x squared minus 1. Expanding out the first bracket on the inside, and then collecting everything together, and then expanding out the outside brackets. 3 lots of g of h of x comes out as 12 minus 18x squared. For h of g of x, this time we're embedding g of x into h of x. So I'm taking my function for g of x and I'm putting it in h of x. So it's going to be 2 lots of g of x squared minus 1, 2 lots of 1 minus 3x all squared minus 1. I need to square the double brackets first, rule of BODMAS. 1 minus 3x all squared goes to 1 minus 6x plus 9x squared. Then I'm going to expand out the 2, so 2 minus 12x plus 18x squared minus 1. Collect it all together, we get 18x squared minus 12x plus 1. I like to have the larger power of x at the front if it's positive. Okay, so now going back to the original question, we're looking for solutions to the sum of those two parts being equal to 0. So I'm going to take my 3 lots of g of h of x, add h of g of x, and equate that to 0. And the 18x squares cancel really nicely, and we're left with 13 take away 12x after those have cancelled, being equal to 0, add 12x to both sides, divide by 12, and so the only solution to this one is 13 over 12, therefore there is only one solution. Well done if you got that one. Alright, bye.